Today we will be discussing a clock problem. So, given that after spending a few hours outside on a warm sunny day, Kanishk is home. He looks at the clock and notices that it's 3 in the afternoon. He also notices that the hands of the clock form a right angle. So, as you can see from the first clock here, it's 3 p.m. and the hands of the clock, the hour hand and the minute hand form a 90 degrees angle. So this makes him wonder as to when the hands of the clock will form a 90 degrees angle again. So he wants to know like what is the exact time that the hands of the clock will be at 90 degrees again. Intuitively, if you look at the second clock, intuitively the hands of the clock will be at 90 degrees between 30 and 35 minutes after 3 o'clock. So they will be at 90 degrees between 30 and 35 minutes after 3 p.m. But we want to know the exact time as to when that is happening. Okay, so let's consider like let's say this distance, the distance traveled by the minute hand. Let that distance be dm. So dm is the distance traveled by the minute hand from the 60-minute marker, and let's say d of h is the distance traveled by the hour hand from the 60-minute marker. So d of h is distance traveled by the hour hand from the 60-minute marker. Let's say the distance x is the distance between the 30-minute marker and the minute hand. So let's say this distance is x. And similarly, let's say y is the distance that the hour hand travels from the 15-minute marker. So as the minute hand moves, the hour hand moves with it. So let's say this distance is y between the 15-minute marker and the hour hand. Okay. So we know that distance traveled by the minute hand, the distance dm, this distance is equal to distance 30 minute is the distance traveled to reach the 30-minute marker. So 30 plus this distance x plus x, this distance between the minute hand and the 30-minute marker. So it's 30 plus x. Similarly, d of h is equal to the distance traveled to reach the 15-minute marker plus the distance traveled y. Okay, so 15 plus y. In addition, we also know that in order for the two hands to be perpendicular to each other or make a 90 degrees angle, like this distance between the two hands, the distance between the two hands, like here, should be 15 markers. I mean, then two hands need to be apart by 15 markers in order for them to be perpendicular. So we can say dm minus dh is equal to 15. The two markers, two hands 15 markers apart. So dm is 30 plus x minus 15 plus y is equal to 15. Or in other words, 30 plus x minus 15 minus y is equal to 15. Or 30 minus 15 is 15 plus x minus y, 15. These two cancel off. So x is equal to y. So the distance that the minute hand travels past the 30-minute marker is the same distance that the hour hand travels past the 15-minute marker. So this x and y should be the same. Okay. S of m is speed of m, speed of the minute hand. Okay. And S of h is speed of the hour hand. Now if you go back to our clock again, the time taken by the minute hand to complete one revolution or to travel 60 markers is the time taken by the hour hand to travel 5 markers. We know that the hour hand travels 5 markers, and in the same time the minute hand travels 60 markers. Okay, so we can write S of m divided by S of h. So the minute hand travels 60 markers, and in the same time the hour hand travels 5 markers. Or in other words, S of m is equal to 12 times S of h. So the speed of the minute hand is equal to 12 times the speed of the hour hand. Okay. Now let's say we know that dm is the distance that the minute hand needs to travel in order for the two hands to be perpendicular to each other. So we can say speed of m is d of m and divided by t, distance traveled by the minute hand divided by t. Let's say t is the time taken by the minute hand to travel distance dm. So and we know that the time that the minute hand travels distance dm, the hour hand travels distance y. Because the hour hand moves at a slower rate than the minute hand, the hour hand only travels distance y from the 15-minute marker, because the hour hand is starting from the 15-minute marker because it's 3 p.m. in the afternoon. So the hour hand is starting from the 15-minute marker and it travels distance y in the same time that the minute hand travels distance dm. Okay, so we can say s of h is y divided by t, and y is the distance that the hour hand travels in the same time. Okay, now we know that s of m is equal to 12 times s of h, so d of m divided by t is equal to 12 times y divided by t. We know d of m is 30 plus x, so we can say 30 plus x divided by t is equal to 12 times y divided by t. This cancel off, and we also know that y is equal to x. We just calculated that x is equal to y, so we can write 30 plus x is equal to 12 into x, or 30 is equal to 11x, or x is equal to 30 divided by 11. Okay, now we know that d of m is given as 30 plus x, so distance traveled by the minute hand d of m is equal to 30 plus x, and x is 30 by 11, so 30 plus 30 by 11, which is equal to 30 multiplied by 11 plus 30 divided by 11, which is 30 multiplied by 12 divided by 11. Okay. So distance traveled by the minute hand is equal to 360 by 11, which is the same as 32 8 by 11 minutes past the hour. So the time is 32 8 by 11 minutes past 3 o'clock is when the two hands will be perpendicular to each other. Okay, now let's consider this factor here, 12 by 11. Let's look at this factor, 12 by 11. Let's look at this factor, 12 by 11. This is called as the correction factor. It is used as a correction factor to account for the distance traveled by the minute hand past the 30-minute marker. So in this case, the minute hand must travel past the 30-minute marker. So this 12 by 11 is used as a correction factor to account for that extra distance traveled by the minute hand. Okay. Now this correction factor can be used for a variety of other problems. So let's say that you have another clock and it's 3 p.m. and you want to know like when the hands of the clock will overlap each other, okay, after 3 o'clock. Okay, so we know that in order for the two hands to overlap, the hands will be overlapping between 15 and 20 minutes. Okay, somewhere between 15 and 20 minutes. We know that intuitively based on how the clock functions. So the overlap between 15 and 20 minutes after 3 o'clock. 3 p.m. Okay. Now, in order to find the exact time, what we'll do is like we'll take the 15-minute marker and multiply that by the correction factor, 12 by 11. That's the correction factor, which is equal to 180 by 11. Okay. This is equal to 180 by 11 is equal to 16, 4 by 11 minutes. So the clock, hands on the clock will overlap 16, 4 by 11 minutes after 3 o'clock. So we can use the correction factor to find out when the hands of the clock will overlap. Okay, so they will overlap 16, 4 by 11 minutes after 3 o'clock. Okay? That's how you solve some of these problems.